So from the previous page, we know that there is a need to go backwards, and the way that we're going to go backwards is through what we call an antiderivative. An anti means against. So when you think about this antiderivative, I want you to kind of think about it as it is the opposite of differentiation. So you're going backwards, opposite of our differentiation. Okay, now one thing that is super important, I don't want there to be any confusion about this. So some textbooks will talk about antiderivatives and they'll go through antiderivative this, antiderivative that. Other textbooks will talk about indefinite integration. These are the same thing. So please, like if you're talking about antiderivative, you are talking about an indefinite integral. Okay, so they are the same concept. All right, so on this page, this is mostly just to introduce the idea of the definition of an antiderivative. And the definition of an antiderivative, again, we're trying to go backwards, so it's going to be kind of awkward the way they phrase this. So it's find a function capital F whose derivative is little f of x. Okay, so what we want to do is we want to find this function capital F. Now, the whose derivative means we are talking about capital F's derivative. So we want to find capital F where or such that capital F's derivative is equal to little f of x. Okay, and in this particular problem, they've told us that little f of x is equal to 2x. So we want to find this capital F function such that capital F prime's derivative is equal to 2x. Okay, so we're going to kind of pull this out from thin air. We're going to say, okay, well, let me try this. Let me say if capital F of x is equal to x squared. Would that satisfy this condition that the derivative is equal to 2x? So if capital F is equal to x squared, if I differentiate that capital F, x squared's derivative is 2x, and so that will work. Okay, so that tells us that this capital F function is called an antiderivative of little f. And that antiderivative definition is really encapsulated in this equation here, that capital F's derivative is equal to little f. Okay, so the formal definition of an antiderivative is that capital F prime is equal to little f of x. Okay, and you kind of feel like you're going in a circle here because we're trying to go backwards from the derivative. Now, it is going to be an antiderivative. It is not the one and only antiderivative, because if you think about capital F being equal to x squared, that would also satisfy the 2x for capital F's derivative. So this would be another antiderivative. Okay. Now, if you look at x squared plus 3x, if I differentiate that, I get 2x plus 3, and that does not satisfy the capital F prime's derivative is equal to 2x. So there is going to be more than one antiderivative. Specifically, it is going to be when you add any constant, you will also get another antiderivative. Okay, so this adding any constant, we are going to encapsulate that, the adding any constant, with a plus C notation. Okay, now I want to be really clear about something. You guys, this page 22 is just for your information to kind of get us introduced to the antiderivative. You're not going to have to like memorize this definition on your test or anything like that, but it's just to introduce you to the concept of an antiderivative.